Hi everyone, this is Dr. Vishal Sharma of the Carrier Ethernet LinkedIn group, and I'm delighted to be here with another edition of CE Live. And today I have a number of different interesting topics to talk about that were all discussed in the group last year, this past week, actually the week ending March 1st. But before we kick it off, let me start off as I do always by showing you all what the agenda for today is. I'm expecting a guest, Yang Kao of Parallel Wireless. So if Yang shows up, this was a very last minute thing. I really appreciate his agreeing to be on this CE Live. Then we will have a discussion with Yang. Otherwise, I will take that discussion forward myself. So today's focus is on network performance, lifecycle service orchestration, a little bit about net neutrality. Obviously, that was the big news in the last couple of weeks. And we'll talk about mobile video explosion. Service chaining, I just realized that if I have to discuss the type 2 EPL service, there probably will not be enough time to look at service chaining in depth. But I am going to give you all a quick introduction to the problem that I was going to be talking about, and I'll probably make a separate discussion for that. Hopefully, I'll bring Ahmad from Telecom Malaysia to talk about that with us. So our agenda for today is I'll talk first about network performance. Then we look at what is lifecycle service orchestration that the MEF has been talking about and has introduced recently. We'll, of course, look at FCC's two key decisions that were taken about a week and a half back, and what that impact is on sort of broadband in the US. And of course, the same decisions may cascade to other parts of the world with their own regulatory bodies doing the same thing. So that would have an impact in other parts of the world, perhaps in the years to come. And we'll talk a little bit about mobile video traffic growth, and that's such a fascinating area. And thanks to Patrick Lopez, who's been sending us a lot of good information to the group on that, is the rate at which that growth is happening. And then finally, we'll talk about a very interesting question that Yang Kao brought up with regard to what is the use for a type 2 EPL service, which has been defined by the ITU in G.8011, but a corresponding parallel doesn't really exist in MEF 6.1. And then, of course, the Q&A. So let me also show you all very quickly where we'd like the Q&A to be. As always, the Q&A is best done on the LinkedIn group, and let me show you where that discussion is, so that if you haven't already seen it, you can quickly go to that. And just a moment here. So that's the discussion I posted, which talks about this Hangout and all of the details of this Hangout. So typically, at the bottom of this discussion, where it would be great for you guys to put your questions. Oops, looks like that's, sorry. That's the last one. Let me quickly go back here. And get the discussion that talks about, here it is. So what's up with network performance? That's the discussion you want to go to in the group. And at the bottom of that is where we would like to have all of the questions for everyone. So I gave a good agenda there. And then at the bottom of that, I periodically will do a call out for questions. If you have any questions, you can send them there. Or you can also send them to me at celive@metanoia-inc.com. And I'll check that email on my smartphone silently here. And if there are any questions, we can answer that. So that's about the Q&A. And now let's jump right in to the first topic of the day, which is, as I told you in the agenda, is about network design. And actually, this is an excellent article that was written by one of the VPs at InfoVista. And he had 4 recommendations for doing sound telecom service delivery. And really, to do that effectively, you have to think about network design in a fundamentally different way. And you have to think about what are the steps you need to do in the way you think about network architecture and design, so that you can actually avoid what he calls the mean time to repair. I mean, mean time to repair fundamentally already acknowledges that there's been an error in the network. There's a failure, and now you're trying to rush to fix that. A more sound strategy, obviously, would be to minimize, of course, mean time to repair, but maybe not have as many repairs to do in the first place. And there are 4 principles that were explained in the article that's pointed to in the mind map that you will find linked at the bottom of this video once the Google Hangout is up. The first, of course, is to focus on proper network design. And this is particularly important for mobile video and mobile networks, and the transport part of the fixed network, because the transport part of the fixed network forms the ground layer infrastructure on which everything else is built. And interestingly enough, a lot of the anecdotal evidence by talking to a number of the providers and people who provide tools to detect problems is the following. And I mentioned that in one of my other videos that I did in my Conversation with Experts series a couple of years ago. And the problem is the following, that a lot of the L2, L3 problems that actually show up are really not L2, L3 problems at all. They are the result of L1 problems in the transport layer. So if you can do fixed transport design well, and you have your OAM and infrastructure done well there, then that is what is going to lead to an efficient network design and the greatest ROI. The other principle of the 4 is early detection. So obviously you want to detect issues before they impact customers, which means you need proactive performance management and proactive detection in the network. So, and that has to specifically focus on issues that you see recurring a lot in your network. For example, if your link latency is going up and you're seeing due to a load, excessive loading on the link, that's something that you should have techniques in place, and there are technologies available today to do that, to monitor the loading on the link and say, hey, my loading's exceeding something that I know is going to create latency problems. Let me do something about it. For example, transfer traffic to a parallel link, or transfer traffic to an entirely different path, or take the most high priority traffic and put it down a path that has higher reliability and so forth. So that's early detection. Similarly, if you see a lot of handover issues in a wireless network, well, that's a clue right there that something's not right between the loading that you have between adjacent cells, or the way the signal is caught between a user in one cell and as the user transitions to a different cell. So early detection is the key, and really the mean time to detect is the focus rather than having mean time to repair. And finally, it's not the network impact that's important, it's the customer impact that's important. Why is that? Because you know what, even if your network came down or a certain part of your network came down, but you had mechanisms in place to not impact the services and applications, well then that's what matters, because that's what the end customer cares about. That's what the end user of the service sees. He's only interested in the service delivered by the network. And so the end user perception matters. So you have to keep that in mind. So even if you can have a strategy built in where systematic failures cause certain parts of the network to go down, but you've already factored into it how the user's services will either transition or be unaffected by the impact that the network has had. And if you can mitigate the user's impact, you can go at the back end and in the background repair your network, but the user is not affected. And finally, and this, if you think about it, is kind of a logical thing, is you got to improve root cause analysis. Because anytime a problem happens in your network, you take time to find what's the root cause, right? I mean, if you had increased latency or a link went down, you'd have to do some amount of debugging to figure out the root cause. So if you can find out the failed network condition very, very quickly, you improve the rate at which you can, of course, repair the service. Now, the reason root cause analysis is tricky is because it's often the result of a cascading network condition. It's not always just one thing that causes a problem. As I told you earlier, if an L1 link is oscillating and you're having bit errors go up there, that's going to maybe show up as packet loss in L2 and L3. So if you were only looking at things at L2 and L3, you'd suddenly see packet loss, low TCP throughput, and so on and so forth. But the real cause is an oscillating link at L1. And so that's a cascade that has happened that you need to be aware of and that you need to know how to deal with. So that's the critical thing here. So this, in summary, the idea is that better network design, early detection of problems, at the impact on the end user as opposed to the impact on the network, and focusing on how quickly the time for root cause analysis is the key to better network design and offering a sound telecom service. And that is what's going to take us beyond just thinking about mean time to repair, which is kind of already acknowledging that a failure has happened. And really, in today's world, you do not want a failure to happen, or you want the ability to mitigate the impact of that failure should it happen. So the next topic I want to move on to quickly is what's with lifecycle service orchestration by the MEF. And for that, I actually want to bring up an image here of a very nice article that was written in the MEF. Let me see if I can get that up for you all. There you go. All right, so let me do a screen share. What happens in a screen share is that particular window has to be open for me to be able to pull it up on a screen share. So now you're going to see this nice article. This is on the Ethernet Academy website. And the reason I pulled it up is because it helps to illustrate sort of the motivation behind LSO, or Lifecycle Service Orchestration. So let me start with the third network first and foremost. Okay, let me just share this with everyone so everyone can see this. All right, so the idea behind the MEF's third network is to create agility to combine the agility of the internet and the service assurance that is possible by using carrier Ethernet. And to combine the two, you get a third network which has extremely agile and extremely robust in terms of service assurance. And then, so what is the idea behind LSO? So the key idea behind LSO is basically to reinvent the OSS stack and therefore enable operators to interconnect their OSS to support on-demand provisioning of services. So the idea is that a user should be able to create, modify, terminate connectivity on demand via a web portal or via some kind of a business application, and they should be able to do it in the ideal case literally in minutes, as opposed to hours or days that is normal today. And the whole idea is really motivated by enterprise services, that enterprises should be able to obtain bandwidth on demand, and they should be able to turn up virtual machines in even a cloud provider's data center in a very dynamic way. Now, how do you achieve that? And what's the motivation? Let's look at this figure here. So today, a number of different tasks that are done by the OSS are done by siloed applications or siloed capabilities. For example, network performance monitoring, service assurance, service analytics, service usage monitoring, fulfillment of the service itself, setting up the service when a customer requests. So between the time you actually get the request from the customer and the time you actually deliver a service to the customer, that's fulfillment. And finally, control and modeling the control of the network. All of those are, as you can see, siloed operations happening over 3 layers of an underlying network, an IP/MPLS network at L2 or L3, an Ethernet network at L2, and finally an optical transport network. And if you're going to offer, therefore, if you make any change at any of the 3 networks, that has to be reflected in each of these silos that are there, that are in the operating support system part of the provider's network. And that's obviously very time consuming and not suitable for making an agile network. By contrast, what you really want to do is to have these 3 networks, but within each network have this idea of lifecycle service orchestration, which is a common layer, maybe using the new concept of NFV and SDN, SDN for control, NFV for virtualizing and more economically realizing several network capabilities. And they are controlled in each layer of the network using this concept of lifecycle service orchestration, where you've combined these siloed operations. And by doing this, there are 3 properties that you really want to provide. And there are 3 key characteristics. One is agility, which is the ability to rapidly introduce new services on demand. And as I said earlier, that's by abstractions and APIs that are going to be provided for the applications or the user to request a certain service from the network and to get a certain quality of service and a certain connection from the network. The other property is assured, which basically means you should get consistent performance and you should get robust security. And again, as you can imagine, if you have a siloed operation support system, first of all, monitoring performance is very hard. Ensuring consistency of performance is very hard because your analytics engine and the performance engine are not talking to one another, and now you got to, somebody somewhere has got to take the information from that, correlate it, figure out what's going on, and then and only then make a change in the network. By contrast, if you had the LSO model, you'd have an LSO layer which is in common talking to different layers of the network depending on whether it's layer 2, L1, L2, or L3, and figuring out all of these, the performance as well as the analytics together, right? And the last characteristic, as you might imagine, is orchestration. So the service needs to be agile, it needs to be assured, and it needs to be orchestrated, which basically means you must have the ability to do automatic service management across multiple operator networks, all right? And as you can imagine, that's clearly not going to happen in a siloed environment. So this is a nice little tutorial on the Ethernet Academy website, which of course is linked through the mind map that I always make available at the end of a CE Live session. So if you want to read more about it, this is where you probably want to go. And actually, let me quickly take you to the mind map next, because that's worth looking at itself. Let's do that right away. So you know what I'm talking about. So this is what we are looking at. Let me share it with everyone so everyone can look at it. So that's the mind map. And these are all of the issues that we are covering. I just covered network performance. I'm talking about lifecycle service orchestration right now. And when you get the mind map, if you click on this little plus sign, it opens up to a lot of interesting references. And what I've given you are the references to the article I just talked about. There's also nice white papers and descriptions on the MEF wiki and the MEF website that you want to go look at. So this mind map is what you're going to actually be having access to at the end of the broadcast, and it will have links to, of course, the key articles for the week, as well as interesting references where I thought references make sense. And talking of references, I want to move on to the next topic, which is net neutrality and what has been going on with the FCC decision. So the FCC actually, for those of you who may not be aware of, or even if you are following, there were two key votes that the FCC took towards the end of February. And if you go to the mind map, you'll see that I've actually not just given the article that was posted by Mike Clem on the group, I've also given you a reference to a very nice interview where a professor who's a net neutrality expert talks about the impact of the FCC decision. I'm going to talk about that right now. So there were two votes, as I said earlier. One is that the FCC voted to overturn the state laws that today ban a municipality or municipal authorities from building their own muni-fiber networks. Now, why is that significant? Well, that's significant because if you overturn that, you open the door for local municipalities to start building muni-fiber networks. Now, those that have followed that in the last 10 odd years know that muni-fiber networks have been, have varied between being spectacular successes and complete bombing and complete failures, because that's an investment that needs to be made. And after the investment is made by a municipality, you still need somebody to actually run the network. And that's been the problem in many cases where fiber was laid, network is built out, and then there's nobody to run the network, and now you have a problem. You really can't offer broadband service. So municipalities would potentially be freed from this. Now, this is not something that's not going to be challenged. There is an expectation that this decision would be challenged because there are obviously two sides to the story. So the one is the cable and the incumbent guys, the AT&Ts, Verizons, and other operators of various sizes that are obviously screaming bloody murder because it's unfair competition. If you allow the public to fund their own muni networks, potentially you have an unlimited source of funding by issuing public muni bonds, and you can build fiber networks all over the country that are in direct competition to the huge network investments made by the operators themselves. So obviously they're not in favor of that because now you have a taxpayer-funded initiative that can have unlimited funds. On the other hand, of course, are the OTT operators, who would favor this happening. And as you know, Google is already doing that. It's cherry-picking markets, starting with the Kansas market and other markets in the US, where it's actually laying out fiber for free. And it's actually building partnerships with the municipalities saying, look, we'll lay out the fiber, we'll start offering service. You maybe in the meantime figure out how you might take that over from us or how you might partner with us. So there are markets in which this partnership is happening. But of course, the expectation, the interesting thing for broadband is this going to actually increase deployment of broadband? And my personal feeling is that even if it does, it's going to be a long time coming. And there's going to be a lot of contention that happens in the meantime, because this thing may likely go all the way to the Supreme Court, and somebody's going to have to make a decision whether this is even allowed or not. So there are two sides to this coin. One, a municipal land fiber rush where people are running in to build fiber while this rule is being debated, and the FCC decision allows them to do that. On the other hand, potentially it can be a disaster if everything goes to litigation and a decision is made that overturns the FCC decision. So that's the first part of the FCC decision. The second part of the FCC decision was that they decided that broadband services, including mobile broadband, come under what's called Title II, because they thought that broadband is an interstate subject, it has interstate coverage, and therefore it can be regulated by the FCC. And in particular, they decided that mobile data broadband is also comes under the purview of the FCC, and so they voted to do that. Now, once broadband comes under Title II, what that really means is it becomes a service. A lot of things can be regulated, and more importantly, because of that regulation, the FCC can dictate that you observe net neutrality. And what is net neutrality? Well, net neutrality is a lot of different things to a lot of different people, but fundamentally it's the idea that you cannot discriminate against traffic that is going on your network if you're an operator. So I've given you links to some nice articles here that talk about the impact of the FCC decision and what that means for traffic. You can, of course, read that at your own leisure, but fundamentally, the idea, there are two arguments to be made. One is an economic argument, which says, look, if you start charging, if you go away from net neutrality, you start charging different content providers like Amazon, Netflix, Google, YouTube, they start paying for content, then potentially they have the ability to pay a higher price and essentially block out the little guy. So imagine little Joe Schmo sitting in a corner somewhere building a nice little mobile app, and users start using it, but then because of the absence of net neutrality, there's no bandwidth available for Joe Schmo's application to ever be downloaded by you on your mobile phone, because all the bandwidth is consumed by those who are actually paying for that service. What that means is that now these small companies and small developers do not have the opportunity to reach out to the customer, and that kind of throttles that kind of innovation. And the other sort of other sort of non-economic argument is that it gives way too much power to the operators, because now they have all ability to control what content actually reaches the end user. And that's something to actually focus on a little bit, because if the ability to pay for access to the user, so if I can pay to get high priority on the user, on a provider's network, to get access to you as the end user on your mobile phone, iPad, or end device, I then can control as the operator who pays me the most, and I can control what content actually gets to you. And so content is no longer, you don't really have access to all the content. So that does have an impact on the user's ability to freely choose content. And so that's a non-economic argument that was made for net neutrality. So for the time being anyways, the FCC has decided that net neutrality is the way to go. So operators cannot directly charge differential pricing for service. They also cannot give differential treatment to traffic for service. So two things here. One is traffic management, one is the economics in charging. And if they can't do that, then what does that mean for broadband? Well, for the time being, it means that the pipes are open, the access to the end user is open for Joe Schmo mobile app developer as much as it is for Netflix or Amazon or Amazon Prime services. But again, this decision is not cast in stone. It can be challenged, and the coming few months are going to show us if that challenge is actually going to happen or not. Now let me move on to giving you some very interesting stats on mobile apps, which of course are linked in this mind map. And let me go away from the mind map for a minute and give you some interesting statistics that actually came from a report from Ericsson, just a little before the Mobile World Congress. Now, what the Ericsson report shows is that in the next 6 years, that's between 2015 to 2021, the mobile video traffic is going to grow 17-fold relative to what it was in the previous 6 years, which is from 2008 to 2014. And if the study showed that 66% of the application data, the mobile app data, is actually consumed by just 5 applications in every country that they study. And in the US and even in Europe, in Spain, for example, 16 and 20% of the mobile app traffic is Facebook. In the US, if you break it down further, Facebook is first at 16%, YouTube is second at 15%, and Netflix is third at 12%. In Spain, Facebook is first at 20%, and Instagram is second at 13%. So the interesting part is that it's hugely skewed, the 80-20 rule. It's more like the 99-1 rule. Majority of 99% of the traffic volume is constituted just by a handful of apps you can count on your fingers. And the interesting part is that 45% year-on-year growth is projected for this mobile data traffic, especially video, in the last until the year 2020, so in the next 6 years. And by that time, mobile data traffic is going to make up 55% of all mobile traffic. And so that's kind of the statistics, which was so interesting that I thought it would be worthwhile to quickly share that on a CE Live session and share that with the group. All right, so with that, I think I'd like to go into the technical part of today's discussion. So I don't see that I have Yang, who's been able to join. So let me actually walk you through the problem that we were discussing and walk you through both ITU and MEF documentation on that problem space. So let me first show you the discussion itself. And as always, I gotta find the discussion, and then only am I allowed to share it with you all. So let me take a minute here, do the screen share, and bring up that discussion. Here goes. So this is a sort of question that was posed by Yang Kao of Parallel Wireless to the group about 2 weeks back. And so Yang's basic question was, he's trying to understand how are Ethernet codes faithfully and transparently transported across a long haul link. I mean, he's thinking about it in the context of wireless networks and backhaul. And the question was, look, is there a way to faithfully transport Ethernet codes across a long haul link? And Yang's thought was that the ITUT in G.802.11.1 defines two types of EPL service, a type 1 EPL service and a type 2 EPL service. And Yang's thought was that the type 2 EPL service is one of the services that allowed for this transparent transport of Ethernet control codes, and also for better quality of service. But what I'm going to show you here once we go through the technical discussion is that actually that's not the case. Even though the MEF does not have a parallel to the type 2 EPL service in ITUT, that's more of a specialized service in my view, and I welcome inputs and questions and feedback from people either right now, and I'm checking the question bank here in the discussion in case somebody's posted a question, or later on. But let me share with you the description as seen in the MEF documentation and in the ITUT documentation. So let me just do a quick change of screen share and take you to my screen where I have both of those documents open, and I've highlighted some interesting parts that I think are worth for us to talk about here, and I'll walk you through that. So let me do that right away. Oops. There you go. All right, guys. So at this point, you're going to see two documents open side by side. All right. The one on the left where we see this diagram, as you can see, is from G.802.11.1, and the one on the right is from the MEF. It's MEF 6.1. So now the key issue here is that both MEF 6.1 and 802.11.1 define what's called an Ethernet private line service. However, their definitions are a little bit different, and this is a subject that was discussed a couple of years back on the group, and a pointer to that discussion, which is a very interesting discussion, is also provided under Yang's discussion. But let's just look at what the two organizations do in terms of defining an EPL service. So on the left here is the definition from the ITUT, and it says an EPL service is a point-to-point service between two demarked points, and here are the demarked points, right here. That's essentially the link that connects the uni-N to the uni-C. And the service is provided over, in the ITU terminology, a connection-oriented server layer network. So a connection-oriented server layer network could be an L1 network like OTN, it could be SDH SONET, or it could be any one of the other circuit switch technology that we might want to use. And it's a connection-oriented server layer network with committed information rate. Now, if the connection-oriented network is packet switched, which means I think the analogy here might be to an MPLS network, then of course you need traffic management to ensure that your committed information rate is indeed maintained. All right? And in the ITU terminology, they define two levels of transparency for an EPL service, and that's where the two types of EPLs come in, type 1 and type 2. So in type 1 EPL service, it's the frame-based characteristic information that is transparently carried between these two demarc points. And what is the definition of a frame-based service? That's again given here. The idea there is that when you receive an Ethernet frame on the uni end across this demarc point, you strip away the Ethernet physical layer, which is basically you take away the encoding on the physical layer, and you take the actual MAC frame, and that's what is transported across the transport network between the two uni ends. And then at this point, as it goes across the demarc, the physical section layer of Ethernet will be inserted again, and the Ethernet frame with the physical layer complete is what's going to be received by the network. So in this case, as you can see, what's actually traveling across the transport operator network is just the Ethernet MAC portion, not the actual physical bits that may have been received on one side. So your physical encoding on the two sides could potentially be different. All right. Now the type 2 service is a more transparent service, and the idea there is that it's actually a service, in my opinion, that was designed with two very special rates in mind: a 1 gigabit per second and a 10 gigabit per second service. And the reason for that, so let's first look at what a type 2 service is defined to be. So it's a service that's defined to be one where you just take the signal that's coming at your demarc point. You do not really extract the MAC frames, but you just take that bit stream as is, and you encode that on the physical transport network, the layer on which you are actually carrying that Ethernet frame. So the exact definition is that is defined the 8-bit, 10-bit symbol stream. Actually, it's either 8-bit, 10-bit. For 1 gig and 10 gig, the encoding is 8-bit, 10-bit. For 40 gig and beyond, the encoding is 64 bits to 66 bits. So the EPL Type 2 service currently is only defined for 1 gig and 10 gig. So it's talking about taking an 8-bit, 10-bit symbol stream within the interface signal that you're getting across the demarc interface, and it's simply transported through your transport network as is, raw. So you're not really trying to identify and extract the MAC frames. You just take the physical bit stream and you transport it. However, this Type 2 service is only defined for 1 gig and 10 gig rates. So, and the reason they did that is because 1 gigabit per second rates, if you go look at Appendix A and B respectively of this document, maps very well in the Sonnet SDH world to a VC4-7C virtually concatenated stream. And a 10 gig service maps to a VC4-64C continuously concatenated stream. So those are the special rates where it's possible to just take the incoming bit stream and pipe it directly into a Sonnet SDH circuit of a certain size. But that's not a general purpose, as you'll see here, this is not a general purpose mechanism to transport a variable bitrate stream in this transparent fashion. So you can't actually do that. You can either do 1 gig or 10 gig, you cannot do sub rates. Whereas in a Type 1 service, since you're taking MAC frames, it's a lot more flexible. You can actually transport sub rates. All right. So the Type 1 service is really the one that is the more flexible one. And if you come on now to the document on the right-hand side, let's see how the MEF defines a transparent Ethernet private line service. So in the MEF definition, an EPL service, of course, has to use the E-line service type, because in the MEF takes, as you know, a services view of the network. So any service is defined by the service type, and each service type then has attributes, and then the service attributes have parameters that have values. So there's 3 levels to be defined. You need to know the service type, which of course for an EPL service is the E-line service type. The E-line service type has certain attributes, and those attributes have values that are, parameters that have values. So an EPL service in the MEF terminology is a point-to-point Ethernet virtual circuit between two unis. And look what the MEF says. It provides a high degree of transparency for service frames between the unis that are connected. So the MEF defines only a high degree of transparency. Why? Because most fields in each service frames are identical at both ends. So some fields may change, and you have to actually go look at the tables in 6.1 to see, and actually in 10.3 as well, to see which fields are transported as is and which fields are changed. And that, if you look at those tables also define, to Yang's point, how the L2 control protocols and Ethernet control codes are transported across the provider network. And this relates to another discussion we had at the last CE Live, that there are certain rules for which L2 control protocols are transported transparently, which ones are dropped altogether, which ones are transported with some change in certain fields, and that's defined in 10.3 and some parts of 6.1, and you need to go there to look at that. But the basic idea is this. So in reality, as I'll show you in a moment, the ITUT EPL type 1 service type can actually is in some sense a subset of the more general Ethernet private line service that's been defined by the MEF, and this service type is actually can be used to realize a MEF EPL service. And to show you that that is indeed the case, let's go to page 23 of this document. And you'll see that right here the MEF document says, the ITUT says that the MEF E-line service type defined by the MEF documents can be implemented using the EPL services defined in this recommendation. And then they go on and tell you how the MEF EVC service attributes and the service attribute parameter values are actually mapped to the Ethernet circuit attributes defined by the ITU and the Ethernet circuit values. All right. So to Yang's point, there are mechanisms in the MEF specs as defined today, using in combination with specifications from the ITU to transport the L2 control protocols and the Ethernet codes across an EPL service type, even if you're only doing a type 1 service. And in fact, the type 2 service, just to summarize, is designed for special cases which only apply to 1 gig and 10 gig rates. So that's my take on the EPL service types. And let me quickly see if I have covered the points that I wanted to cover. So we've talked about network performance. We've looked at LSO, and I've given you some clues on where to find good information on LSO and what the fundamentals are about. We talked a little bit about the FCC's 2 key decisions that impact broadband deployment, initially of course in the US, but potentially elsewhere in the network. And I walked you through some very interesting statistics about mobile traffic growth. And we looked at the question that Yang Kao of Parallel Wireless brought up. It's a pity Yang couldn't join us today. I had sent him the link to the Hangout as a guest, but unfortunately I don't see him on the Hangout. So it would have been great to get his viewpoints and his opinions, but maybe we'll do that later on the group and do that at a later point in time. So let me quickly see if there's any questions that any of the attendees have. If you do, now would be a good time to post those to the group, as I'm going to go check that right away and see if there's any good questions that we need to address right now on the Hangout Live. So I'm just refreshing the page. Okay, so I don't see any questions right now. So, so just to summarize, guys, there's going to be a mind map as always that is going to contain pointers to all of the information that I shared with you and some more. And all of the resources that I showed you, the 2 documents from the MEF and the ITUT, will be also linkable from the mind maps. You can actually go there. In fact, what I'll do, I think, is actually I'll upload the 2 documents that I've already just showed you today with the highlights, so it's a little bit easier for you to find the content that I referred to here. So if there are no questions, that's what I wanted to discuss with you guys at the CE Live today. We'll probably try to come back again in a couple of weeks. The service chaining part, let me just talk quickly about service chaining. This was actually a discussion that came up in the SDX Central LinkedIn group, and I'm going to provide a link to that in the mind map. But the basic idea was a very interesting problem that some of the folks at Telecom Malaysia Labs are looking at today. And what they are looking at is they are looking to build a service chain using virtual network functions. And the idea is the following. So let's say you have HTTP web traffic coming in, and you want to identify HTTP traffic in the user's incoming traffic streams, and take HTTP traffic and then even break that down into, let's say, Facebook traffic. And if it's Facebook traffic, you want to route it through one set of network functions. If it's some other HTTP traffic, you want to route it through a different set of network functions. And let's say you have a collection of 4 network functions, VNF 1 to 4, and each of these 4 functions are used in different parts of your service chains, in different service chains. So the question that was asked by a colleague at Telecom Malaysia was, do you need to duplicate these same network functions in each of the multiple service chains, or is it possible that if multiple service chains are using the same virtual network function, I can just instantiate that function once, in a cloud environment somewhere, and then use that single virtual network function, assuming I got enough processing horsepower. Of course, I need to do that calculation, but assuming that the virtual network function has the capacity to handle all of the processing that is thrown its way, and that same virtual network functions is used in multiple service chains, do I need to duplicate that VNF in each service chain, or do I need to use just one VNF? Now, logically, if you think about it, using one VNF is ideally the way you'd want to go, because if you have to spin up one virtual network function for every instance of a service chain, you got a scalability problem potentially. Because if the same virtual network function is used in n service chains, you're going to have n versions of that, and that's not going to be very good. You're going to be spinning up n versions in a virtual machine somewhere. So ideally, you want to use it only once. However, if you want, for some reason, to segregate your service chains, maybe initially in deployment, you want to keep them separate because debugging is easier. As I said, finding out problems is easier. Remember, detection is the key here. If we go back to what we started today's discussion with, then it probably makes sense, at least initially, to have virtual network functions completely separate across service chains. But if you really are looking at it from a scalable deployment perspective, eventually, you would want to have virtual network functions that are used across multiple service chains instantiated only once. And the question is, do vendor implementations let us do that today? And I think the question that came from my friend at Telecom Malaysia, Ahmed Saluddin, was that their vendor was telling them they got to instantiate a VNF for every instance of a service chain, which of course leads to an explosion of VNFs, an explosion of virtual machines, and a scalability problem. Not just in terms of having a lot of virtual machines spinning up, but also in terms of how you're going to monitor and manage those virtual machines. Because the more VMs you have, the more complex your monitoring becomes, the more difficult detection becomes, the more difficult your network design becomes. As the bottom line I wanted to highlight is, simply virtualizing stuff ain't going to make the network design and network performance problems just disappear overnight. You have to think about it differently, and you have to think about it intelligently. So this service chaining, I think, is an interesting problem. I'm going to discuss that in a subsequent, network architecture and design series. Or if I can get Ahmed to come and talk to us, then maybe I'll do a joint session with Ahmed, and we'll talk about that. So for today, guys, these are all the things I wanted to talk about. I thank every one of you who were here live for being here with us today, and those that are going to watch it later. I hope you get a lot of value out of it. And as I always say, may the bits in your bytes and the bytes in your packets be profitable. And I'll see you next time. So talk to you later. Bye-bye.